so let's continue on. This chart is kind of just another version of the previous chart. So this is, again, the previous chart is one that we will use a lot. This one is not necessarily one that we'll be taking a look at. There is some settings that allow you to adjust it. And here it's contrasting the direct normal radiation with the global and total surface radiation. All right, but again, we're not going to be looking at this one too much initially for our design purposes. There is no illumination data that was covered. So the next one that we come to is the sky cover range, okay? And so in January, on average, so this is the average, right? The sky is cloudy more than half of the time and clear about half of the time, okay? You can see that the lowest months of the year are February, which seems kind of odd. Definitely hasn't been like that this year, right? And July, right? Followed by September. We get kind of a pop-up in August, okay? And the reason that we're getting that pop-up in August is because that's when we have our monsoonal season, and that's when we sometimes get a southerly flow coming up from Baja California, and it brings with it clouds and sometimes summer showers, okay? The reason that it's important to know how much global radiation you get and how much sky cover there is because you can use the sun to warm up a building. You can use the sun to gather energy for both water heating and photovoltaics and generation of electricity. Okay, so those are things to take into consideration as you guys are starting to work with the climate in the region to develop a responsive design. All right, wind velocity range is going to give you essentially, what the average winds are. You can see that the windiest month is February. All right, probably January and December seem to be the least windy. And here is the ground temperatures, and I clicked fit to data, okay, so that it kind of gives us it gives us a greater differential between the temperature ranges. So one of the things about designing and understanding soil temperature is that in some climates, it sometimes helps if you have something called earth sheltering, okay? And so if you are, for example, have a project out in the desert, in the low desert, okay, where the daytime highs get so high that the soil temperature might be cooler than the outside air temperature, then sometimes it helps to kind of have the building partially sort of embedded in the ground. Same thing can happen in the opposite direction if you have a climate that has really cold periods that come through, but the ground temperatures don't freeze. Okay. We're not going to look at too much at the combination of dry bulb and relative humidity, other than I want you guys to sort of surmise that they seem to be inverses of each other. When one decreases, the other increases, and that's pretty much the case in all of them. We'll get to this chart later in the semester, but this is a chart that shows the months of the year, okay, the time period of the year, and it shows a color that relates to the warmest times, the average times, and the coolest times, okay? So if you take a look right here, this is December. It's the shortest day of the year, okay? If we take a look for June, it's the longest day of the year up at the top, okay? And you can see the difference between the temperature ranges. Like I said, we're going to take a closer look at this chart later because this chart will allow us to input information related to shading, things that might kind of block the sun from getting to the building. So I'm going to leave that out right now. This one right here is the shading calculator. And this can give you an idea of when shading is going to be most effective. So, for example, if we were to say, all right, well, these hot bands over in here are the ones that we really need to kind of deal with, then we might say, all right, well, we'll take and we'll put shading in so that it does this, and then we'll start to kind of narrow up the range until it kind of meets our requirements. One thing that I want to kind of show you in this chart and talk about this is this idea of thermal lag. Okay, notice that the chart is not symmetrical. The chart is asymmetrical. Look at all of the red down all the way low down in here, and yet the symmetrical part is all cool on the opposite side. The reason for that is because of something called thermal lag, which is that the Earth is a giant chunk of thermal mass, and the sun is an infrared radiator, right? And so the Earth is absorbing heat, and it absorbs heat all summer. But peak heat actually occurs, the hottest time of the year occurs in August, not the longest day of the year, which is in June. And that is because the Earth soaks up the heat until it starts to the days get shorter and cloudier, then it releases the heat. We'll move on from here. This is another one of the charts that just is presented in a different format. These are temperature charts. You can switch it to a monthly average, and that's going to give you the time periods of sun. So remember the chart that we looked at in WeatherSpark? It had something very similar to this. The only thing that this one's not showing you is the time periods where we have daylight savings and it's reciprocal at the end of October. Same chart presented in a different format. And then finally we get to the psychrometric chart. Okay? So the psychrometric chart, if we turn off all of these choices on the other side, we're going to turn off all this stuff. It's going to basically give us the weather picture showing all of the hours of the year, 8,760, versus the time frame of the year that's comfortable, which is 1,037. So it tells us how many of those are going to be essentially either too hot or too cold, and how many of them are just right. Okay? So there's a lot of settings that you can sort of change over in here that we can get into later. Right now, the main thing that I want to show you is some of the strategies that kind of go with this. So when you look at this chart, you might surmise that it seems to have a lot more hours that are cooler than hotter than the average temperature. But the range, how much cooler versus how much hotter, is about the same, right? So the distance from this edge to that line is about the same as from that edge to that line, or to that point, okay? So you might start to take a look at some of the options that are available over in here. For example, high thermal mass, right? If we turn that on, it gives us an additional line. And by including the concept of high thermal mass in a residence, okay, we can now make all of these additional hours much more comfortable. Now, what is high thermal mass? That's something that we're going to get to hopefully today. All right? Now, let's turn that one off. And then there's one directly beneath it that says high thermal mass and night flushing. Now, if you take a look at that, high thermal mass and night flushing extends it pretty close to all the way over. Okay, so what is high thermal mass and night flushing? Do any of you have a whole house fan at home in your house? A whole house fan? It's a big fan, sits in the attic, and you turn it on and open the windows and it drafts the outside air and it takes it out through the attic. You have one? Anybody else? No? It's a very, very effective way of cooling off a house. It's very noisy. There are expensive ones that aren't. Yes, there are expensive ones that are not. But most of them, since the fan is like right there at the ceiling level, right? It's like an airplane goes off when you turn the thing on. It's like the propeller is just turning right up above your head, and they are very noisy. There are the quieter ones. The fan is separated up a tube away from the house, and then inside of the tube it's lined with a soundproofing material that absorbs noise. Okay? But you can see that if we combine this notion of having a lot of thermal mass in a house with the idea of flushing it with the air at night, that we can pretty much start to kind of cool that off. All right? Let me turn that one off. Well, let's contrast the two. So just the thermal mass gets you this far. Thermal mass with night flushing gets you all the way over to there. So we'll turn both of those off. Okay? Let's take a look at passive solar direct gain with low mass. So passive solar means that you're using the sun and allowing it into the house in order to warm the house up. And that's pretty much taking you all the way over into the 40-degree range. Okay? If we turn that one off and turn the next one on, it takes you down below that. So contrasting the two, right? One of them gives you another 5 degrees of ability to heat. Okay? So if we turn both of those off, let's turn on internal heat gain. So what is internal heat gain? What do we mean by that? Do you guys have a refrigerator at home? You have a refrigerator at home. Does the refrigerator produce heat?
Yes.
It does. Does your body produce heat? Yes. Does your TV produce heat? You walk by the TV and you touch the monitor and it's hot, especially if you have a really big one. Okay? So there are a lot of devices inside of a typical residence that produce heat. There might be a water heater. There could be a number of different things that are generating heat inside of the house. If the envelope of the house is well insulated and thoroughly sealed, and you have good windows that seal air infiltration and exfiltration. Okay, so you guys read about infiltration and exfiltration in envelope inside of the Green Studio Handbook. Okay, so by producing a tight envelope, you guys can make a house in this climate zone comfortable that much of the time. So good insulation and well-sealed doors, windows, cracks, etc., plus using high thermal mass and night flushing. Take a look, right? Look at the difference in hours. Now we could take 6,000 out of 8,700 hours that are comfortable using almost no energy, which is why it's referred to as a passive technique. Okay? So you can start clicking the rest of these. Humidification, dehumidification, evaporative cooling. There's a number of different sort of choices that you can kind of select, and they in turn will show you all of the time periods that you can make comfortable. Now if we turn all of these off, let's turn everything off. I don't want to hit 15, so let me hurry it through this stuff. Let's turn that off and turn on heating and cooling and dehumidification, right? So if we use those things, right, it's basically saying that that's going to account for all of the times that are outside of there. And so it's going to pretty much make it to where if we're willing to use an air conditioner and we're willing to use a heater, right, that we can make it comfortable 98.5% of the time. So pretty much 100%. Okay? These are the two that we want to avoid if we are trying to make it to where the building is more energy efficient.